Good morning, children. I hope all of you are very fine and enjoying my classes. Before starting the lesson, I want to tell you that if you have not watched my previous video, that is percentage composition and empirical formula, then please watch it before you watch this video. So let us start our today's lesson. Molecular formula. So what is molecular formula? Molecular formula represents the actual number of atoms present in a molecule of a compound. It is not the simplest ratio of the elements like the empirical formula. For example, molecular formula of glucose is C6H12O6. We obtained the empirical formula by dividing the coefficient of these elements by their HCF, that is 6. You can see the coefficients are 6, 12 and 6. So the HCF is 6. When we divide C6H12O6 by 6, then we obtain the empirical formula. So the empirical formula of glucose is found to be CH2O. Now, how to determine the molecular formula of a compound? Provided if you are given with the percentage composition of the compound, then how can you determine the molecular formula? So there are different steps. Molecular formula is equal to empirical formula into N. What we have already seen before this, that molecular formula is always equal to empirical formula into N, where N is an integer. It may be 1, 2, 3 or so on, and N can be found by the formula molecular mass by empirical formula mass. Now let us try to understand the step in determination of molecular formula. The first step is to find out the empirical formula, and you know, in my previous lesson I have already explained how to find the empirical formula, which contain different steps. And the second step is to find out N by the above formula, which is shown by the arrow mark. You can see where N is equal to molecular mass divided by empirical formula mass. And last step is to multiply the empirical formula obtained by N. Let us discuss this with some example. So first example you see. The problem is a compound is found to possess C is equal to 40%, H is equal to 6.7%, and O is equal to 53.3%. Its molecular mass is 60. Find the molecular formula of the compound. Find the molecular formula of the compound. Now, the solution. What is the first step? To find out the empirical formula. So for empirical formula, we are having different steps. First step, I have written all the data given in the question. That is, carbon, the percentage composition is 40% and its RAM is relative atomic mass is 12. For hydrogen, 6.7% and RAM is 1. Oxygen, it is 53.3% and the RAM is 60. The second step, after this, the second step is to divide the percentage composition by RAM. So you can find here, first thing what I did, 40 divided by 12. 40 divided by 12 is equal to 3.3. Secondly, 6.7 divided by 1. So that is equal to 6.7. And finally, 53.3 divided by 16, which is equal to 3.2. Now the final step for the empirical formula is we have to select the smallest quotient among these three, 3.3, 6.7 and 3.3. What is the smallest question? It is 3.3. Divide all the question by 3.3. So you can find in the first case 3.3 divided by 3.3 is equal to 1. 6.7 divided by 3.3 is equal to 2. And 3.3 divided by 3.3 is equal to 1. And now we can obtain the empirical formula, that is C1H2O1 or CH2O. Now what is the second step? To find out N. To find out N, we must know the molecular mass, which you can see given in the question. And secondly, we should know the empirical formula. So let us try to find out the empirical formula. Empirical formula mass we can calculate from the empirical formula. C is 12, hydrogen 1 into 2, and oxygen 16. Total 30. So empirical formula mass is 30. Now to find out N, N is equal to molecular mass by the empirical formula mass, that is 60 by 30 is equal to 2. And now the final step to write the molecular formula. As we have discussed earlier, molecular formula is equal to empirical formula into N. So here we can find out 2 into empirical formula C2H4O2. Now the second example. Second example is the problem given is find the empirical and molecular formula of an organic compound from the data given below. C is equal to 75.92%, H is equal to 6.32%, nitrogen 17.76%, and its vapor density is 39.5. So in the solution you can see, first step is to find out the empirical formula. I have written all the data here. Carbon 75.92%, hydrogen 6.32%, nitrogen 17.76%, and the relative atomic mass of all these elements are given here. Now the second step in finding out the empirical formula is to divide the percentage composition by relative atomic mass. So first thing what we will do, 75.92 divided by 12, which we get 6.32. Then 6.32 divided by 1, we will get 6.32. And finally what I have divided, 17.76 divided by 14 is equal to 1.27. Now we have to find out the smallest quotient among these three, which is equal to 1.27. So divide all the quotient by 1.27. 6.32 divided by 1.27 is equal to 5. 6.32 divided by 1.27 is equal to 5. And 1.27 divided by 1.27 is equal to 1. Hence, the empirical formula you can get is C5H5N. This is the empirical formula. Now the next step is to find out N. For that we need the molecular formula. In the question, molecular formula is not given directly. But from the vapor density, we can find out the molecular formula. Molecular formula is equal to 2 into vapor density, which is, we can say 39.5 into 2 is equal to 17. Empirical formula mass we can calculate, C5H5N. So 12 into 5, 1 into 5 plus 14, which is equal to 79. Now here N is equal to 79 by 79. You know the formula, molecular mass by empirical formula. So which is equal to 1. Now the molecular formula will be N into empirical formula, that is 1 into C5H5N, which is the same. Empirical formula and the molecular formula are the same. Hence the molecular formula for the compound is C5H5N. Let us take another example. The problem is 0.5 gram of an organic compound contains 0.062 gram of hydrogen and 0.25 gram of oxygen. In the vapor state, this compound weighs 32 times as heavy as the same volume of hydrogen. Determine the molecular formula. So you can see here the solution. First of all, we have to find out the empirical formula. Here percentage composition is not given. And here another thing, organic compound contains carbon. All the organic compound contains carbon. Here it is organic compound is written. That means we have to find out the mass of oxygen. Hydrogen and oxygen is given. So hydrogen is 0.25 and hydrogen is 0.062 gram and oxygen is 0.25 gram. So remaining is carbon. So hence the mass of carbon is equal to 0.5, that is the total mass, minus the mass of total mass of hydrogen and oxygen, 0.25 plus 0.062, which is calculated as 0.188 gram. Now you can see I am not writing here, no need to write the percentage composition. The mass as it is given, we can write here. The weight of carbon I have written 0.180, weight of hydrogen 0.062 and weight of oxygen is 0.25 and the relative atomic mass is mentioned. Now the next step is to divide the weight by the relative atomic mass. So here you can find 0.188 divided by 12, which is equal to 0.016. Then 0.062 divided by 1 is 0.062, and 0.25 divided by 1 is equal to 0.25 divided by 16 is equal to 0.016. Now you have to find out the smallest one. So the smallest coefficient is 0.016. So everything should be divided by 0.016. The first one you can find it is equal to 1. The second one is 4 and the third one is 1. So now the empirical formula of the compound is CH4O. CH4O. Okay. Now the molecular mass you can see in the question. The question reads like this: in the vapor state, this compound weighs 32 times as heavy as the same volume of hydrogen. That is nothing but the vapor density. So the vapor density is given 32. Now molecular mass is equal to 32 into 2. Vapor density into 2 is equal to 64. And empirical formula mass we can calculate from the empirical formula. CH4O, 12 plus 1 into 4 plus 16 is equal to 32. Now N is equal to molecular mass divided by empirical formula mass. So that is equal to 2. Now we can write the molecular formula. 2 into the empirical formula, that is 2 into CH4O, which is equal to C2H8O. C2H8. So my dear student, with this topic I have tried my best to explain you well, and now if you understand, you must do some homework given. Okay, and the homework you can find in your book, textbook, that is page 90 and page 91, exercise 5C, question number 11 to 23. Question number 11 to 23 you must do. Thank you very much. Have a nice day.